So what we're going to do in this video is look at an introduction to trigonometry, which is it's a whole branch of mathematics, but it's actually really one of the more useful things. So it kind of uses triangles and it relates angles and side lengths. And what we're going to focus on just for our class right now is just right triangle trigonometry, which is the most common trigonometry. So to introduce this idea, we're just going to look at kind of an example of how and why we're allowed to use it. I have two triangles here, triangle 1 and triangle 2. We can see they're both similar in the fact that they're both 30 degree, 60 degree, 90 degree triangles. So side A of triangle 1 is 34. That's millimeters. Side B is 59. Side C is 68. Then I'll jump right down to A, B, and C for 2. A is 15, B is 26, and C is 30. So we can agree that all of these numbers are different. But now what we're going to do is we're going to take A divided by B for both triangles. So if I take A divided by B, 34 divided by 59, I get the decimal 0.5963. I'll just go 596. If I take A divided by B in triangle 2, 15 divided by 26, I get 0.596. If I take A divided by C, 34 divided by 68, I get 0.5. If I take 15 divided by 30, I get 0.5. So this is already pretty interesting. If I take B divided by C, 59 divided by 68, I get 0.87. If I take B divided by C here, 26 divided by 30, I get 0.87. So what you see is, regardless of what these numbers are, how they relate to each other is that when we divide the corresponding sides together, you get the same number back. So this leads us to our idea of a trigonometric ratio. So a ratio is just a fraction. Trigonometry means relating to triangles. So all trigonometry is how angles relate to the side lengths of triangles. So our three basic trig ratios are sine, cosine, and tangent. You've probably heard these words before. The sine of an angle, A is an angle, call it angle A, is always equal to the opposite side, which is the side that's not touching, in our case A, little a, over the hypotenuse, which is C. If we go back here, the sine of 30 is A over C, is 0.5. The cosine is the adjacent side over the hypotenuse. Now, adjacent means next to, so adjacent side being the side that's next to the angle but isn't the hypotenuse. So B over C in our case. The tangent is the opposite side over the adjacent side. So tangent does not use the hypotenuse. It's just like A over B. Now we have a little mnemonic device that a lot of mathematicians use to memorize these. That's SOHCAHTOA. That means that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sometimes I'll write it like this, just so I remember. And the reason we care about this is because in two triangles that have the same angle measurements, even though they're vastly different sizes, the ratio between the two sides is the same. So from 30, the opposite side over the hypotenuse is always 0.5. From 30, the adjacent side over the hypotenuse, B over C, is always the same fraction. Now, we have a calculator that can do these for us. Back before calculators were common, old textbooks had huge tables that had all of the sine, cosine, and tangent values for every angle measurement. Before we do a couple more of these for today, I want to kind of hammer home this point about what's an opposite side, what's an adjacent side. So the opposite side from an angle is the side that's not touching the angle at all. So in this case, it's x from angle A but from angle B, it's y. You can make an arrow if you want to do the opposite. Sometimes that's kind of helpful. The adjacent side is the side that's touching the angle but isn't the hypotenuse. So I know this is our hypotenuse, z. So the side that is adjacent to angle A is y. The side that is adjacent to angle B is x. You'll notice these are flip-flopped depending on which angle you're working with. So for today, we're not really going to do any solving. We're just going to set up our next lesson where we're just going to get comfortable with these fractions. So here is a right triangle, 5, 12, and 13. The sine of S, remember, so is opposite over hypotenuse. The opposite side from S is 5. The hypotenuse is 13. Cosine is adjacent over hypotenuse, so the adjacent side is 12 over the hypotenuse, which is 13. The tangent of S is opposite over adjacent, which is 5 over 12. Now, if we work with R, those things are going to get flipped. So the sine of R is opposite over hypotenuse, which is 12 over 13. The cosine of R is the adjacent side from R over the hypotenuse, which is 5 over 13. And then finally, the tangent of R is the opposite side over the adjacent side, which is 12 over 5. We'll do one more page kind of like this. Once again, we're not really solving anything. It seems kind of silly what we're doing right now, probably. You don't have much context for what we're doing. But in our next lesson, we're actually going to solve for missing side lengths with angle measurements. So here we have another one. Let's find the sine of A, cosine A, tangent A, and the sine, cosine, and tangent of B. If you want to pause the video and give this thing a shot on your own, go right ahead. Sine of A is opposite over hypotenuse, 8 over 10. Cosine of A is adjacent over hypotenuse, which is 6 over 10. Tangent A is the opposite side from A over the adjacent side to A, which is 8 over 6. From B, sine is opposite from B over the hypotenuse, which is 6 over 10. From B, cosine is the adjacent side to B over the hypotenuse, which is 8 over 10. And the tangent of B is the opposite side over the adjacent side, which is 6 over 8. And that's really all we're doing today. We're just going to kind of set up these fractions. In our next lesson, we're going to solve for missing side lengths.